Hi, Math 127 students. Today we're working on section 7.4, which is on trig identities. So what we're doing in this section is we're algebraically manipulating trigonometric expressions to resemble other trigonometric expressions. So what I have first is a couple of warm-up problems, just working with sine and cosine and tangent. And then we will do some examples of some proof. So when we get to the section on proofs, we'll talk about that a little bit more. So first problem here, we're asked to rewrite over a common denominator. So we have these two fractions. We're asked to rewrite over a common denominator. So our common denominator here is going to be sine of theta times cosine of theta. So my first fraction here, what I need to do is I need to multiply this by cosine of theta over cosine of theta. And my second fraction, I need to multiply by sine of theta over sine of theta. Okay, next up, we'll multiply this out. So I want to distribute the cosine to both of these terms. So I have sine of theta times cosine of theta minus cosine squared of theta all over sine of theta times cosine of theta. Here again, we're distributing this to both of these terms. Remember, the terms are the things separated by plus or minus. So I have sine times sine, so that's sine squared of theta minus sine of theta times cosine of theta all over sine of theta times cosine of theta. Now that we have a common denominator here, we can add these fractions up. So we add across the numerator. So I have sine of theta, cosine theta minus cosine squared of theta plus sine squared of theta minus sine of theta cosine of theta all over sine of theta times cosine of theta. Next step, we'll simplify as much as possible. So here I see a sine times cosine, here I see a sine times cosine. So sine times cosine minus sine times cosine, those cancel each other out. The last thing we're going to do is just reorganize this a little bit. Usually if we have something with a negative sign in the front, we would put it second as a subtraction sign. So I'm going to write this as sine squared of theta minus cosine squared of theta over sine of theta times cosine of theta. Now be very careful here. This is our final answer. We know, of course, the Pythagorean identity is sine squared of theta plus cosine squared of theta is equal to 1. You want to be careful here though. Sine squared minus cosine squared, we don't have any formula to simplify that, only if there's a plus in the middle. Okay, so this is our final answer. That's as simplified as we can get it. Again, this is just kind of a warm-up problem to start algebraically manipulating these trig expressions. Let's do another one. We are asked to factor and simplify. And I have 10 cosine squared of theta plus 9 cosine of theta plus 2 over 2 cosine squared of theta plus 3 cosine of theta plus 1. Okay, so what we want to do is we want to factor the numerator and factor the denominator, and then we're asked to simplify. So once we have them factored, our hope is that we'll have some terms that cancel out. And on your homework, you should have things that work out nicely where things do cancel out. So what I'm going to do down below is I'm going to do the factorization separately. So first, let's work on factoring 10 cosine squared of theta plus 9 cosine of theta plus 2. Okay, then I'm going to separate this with a line. Then I'm going to factor 2 cosine squared of theta plus 3 cosine of theta plus 1. So I'll do these factorizations separately here. All right, so first one here, you're welcome to factor this with whatever method you like. The method I like is factoring by grouping. So in factoring by grouping, I'm looking for two numbers that multiply to 2 times 10, which is 20, and add up to 9. So they have to multiply to 20 and add up to 9. So those numbers are going to be 5 and 4. So what I do is I take this middle term and I rewrite it as 5 cosine theta plus 4 cosine theta. So you see what I've done here is I haven't actually changed this expression, or I haven't changed this, I've just broken it up into two expressions here. And factoring by grouping, now what we do is group these first two terms together and pull out whatever they have in common. So these both have a factor of 5 in common, and they both have a cosine in common. So I'm going to pull out a 5 cosine of theta. So if I pull out 5 cosine theta from here, I am left with a 2 cosine theta. Pull out the 5 cosine theta from here, I get 1. These two, they have a common factor of 2, so I'll pull out a 2. Now, if you do this factoring by grouping correctly, this should happen. Oops, what did I do here? Oh, I dropped my 2. I'm sorry. Pull out the 2 from the 4. That still leaves me with a 2. Great. So there's a good point here that if you do factoring by grouping correctly, these two things should match. And instantly, since they didn't, I knew that I had dropped something. Okay, so these two expressions in parentheses should match. My next step here, I'm going to factor out these expressions in parentheses, which is going to leave me with a 5 cosine theta plus a 2. So I get 2 cosine of theta plus 1. And then I'm left with 5 cosine of theta plus 2. Okay, so this is my factorization. I want to do the same thing for the denominator here. Then I'll put them into this fraction and we'll simplify as much as we can. All right, so here again, I'm going to do factoring by grouping. So I'm going to look for two numbers that multiply to 2 and add up to 3. So those are going to be 2 and 1. So what I'm going to do is rewrite this middle term as 2 cosine of theta plus 1 cosine of theta. So notice that I haven't actually changed anything. All I've done is broken this up into two terms. Okay, so now we look at these first two terms. They both have in common a 2 cosine of theta. That leaves me with a cosine of theta plus 1. Here, these two terms have a common factor of 1. I actually want to write that 1 kind of as a placeholder so I don't forget that that's what's out there. If we've done this correctly, these two things should match, and they do, so now we pull that out, which leaves me with a 2 cosine theta from here and a plus 1 from here. Okay, so that was our first step, factor. Our next step is to simplify. So what I want to do is write the factorizations up here, and then we'll cancel out any common factors. So we got 2 cosine of theta plus 1 and 5 cosine of theta plus 2 over cosine of theta plus 1 times 2 cosine of theta plus 1. All right, these two factors are in common between the numerator and denominator, so we'll cancel those out. So our final answer here is going to be 5 cosine of theta plus 2 over cosine of theta plus 1. The next thing we're going to do is work on some proofs. So let me show you what's being asked, and then we'll talk about methods of solving. So first one here, we're asked to establish the identity. So this is the wording you might see on your homework, establish the identity. Now, what does this actually mean? This actually means, in other words, prove this is true. So the first one here we have is tangent of theta plus cotangent of theta over secant of theta times cosecant of theta is equal to 1. So far in this class, we've seen a bunch of trigonometric proofs, right? We've seen sine squared plus cosine squared is equal to 1. That's the Pythagorean identity. We've seen all the reciprocal identities, right? Sine is equal to 1 over cosecant, cosine is equal to 1 over secant, etc. So we've seen a bunch of identities already. Now what we're being asked to do in this section is to prove that some other identities are true. So because sine, cosine, tangent, and their reciprocals have these special relationships, there's actually kind of an infinite number of ways we can rewrite these relationships. Some of them are more useful than others. For example, sine squared plus cosine squared is equal to 1. That one's very useful. This formula here maybe isn't extremely useful, right? You might not see tan plus cotangent over secant times cosecant. If you did, you could know that that's equal to 1. The idea of this section is more working on the algebraic manipulation and how these things are related to each other, more than this being like a useful formula that you might see later on in your math career. All right, so if you were taking this class on pen and paper versus our class is on an online homework system, in pen and paper, usually what you would have to do is figure out how to prove this on your own. Now, because we have this online homework system, my math lab is actually going to walk you through this proof step by step, which is a good thing because it gives you a lot of guidance. But if you're planning on being a math major or you have a lot of theoretical classes later on in your career, you might think about how you can actually do this proof before you let my math lab walk you through it. So usually what we do with proofs, we usually would start on the left side of the equation and algebraically manipulate it until it looks like the right side of the equation. Okay, so we'll start with the left side and manipulate it until it looks like the right side. So my math lab's going to give you instructions step by step. So the first one it tells us here is to write the left side in terms of sine and cosine only. And this is a very common approach, sine and cosine. And this is a very common approach with trigonometric identities. Once we have everything in terms of sine and cosine, we can see what cancels out. Okay, so first thing, tangent. We know tangent's equal to sine of theta over cosine of theta. Cotangent's the reciprocal of tangent, so that's cosine of theta over sine of theta. And then in the denominator here, secant's the reciprocal of cosine, so that's 1 over cosine of theta, times, and cosecant's the reciprocal of sine, so that's 1 over sine of theta. Okay, so on your homework, it is going to walk you through these steps. So here's our first step. The next step, it asks you to simplify the expression. So you'll type this in, and then it's going to tell you to simplify. So when we simplify, what we'll do is we'll add these fractions, and then we'll actually do this division. Okay, so that's why we kind of had those warm-up problems to get us used to this algebraically manipulation. So these two fractions in the numerator, our common denominator is going to be sine times cosine. So my first fraction, I need to multiply by sine over sine. So that gives me sine squared of theta over sine of theta times cosine of theta. And my second fraction, I need to multiply by cosine over cosine. So that's going to be cosine squared of theta over sine of theta times cosine of theta. And then my denominator, I'm just going to write this as 1 over sine times cosine. Next step, let's add this fraction. So in my numerator here, I have sine squared of theta plus cosine squared of theta all over sine of theta times cosine of theta. And then my denominator is still 1 over sine of theta times cosine theta. Now at this point, there's a couple different ways you can proceed. First of all, you have a fraction divided by a fraction, so you can take your numerator, switch to multiplication, and multiply by the reciprocal of the denominator. The other thing you can always do is anything that's in the numerator that has a common factor with something in the denominator, right? We can reduce that or cancel it out. So we see here that this has a common, the numerator has this factor of over sine of theta cosine theta, and this also has this factor of over sine of theta cosine theta. So we can actually cancel these without doing the division. If you did the division, you're going to take this, switch to multiplication, and multiply by the reciprocal of this, and then these are going to cancel out anyway. So a couple different ways. So simplifying, we end up with sine squared of theta plus cosine squared of theta. Now on your homework, be careful. It does want you to kind of do this step by step. So the next question is, on your homework, it's going to ask you which identity should we apply? And in a drop-down menu here, we know that sine squared of theta plus cosine squared of theta, that comes up in our Pythagorean identity. So we'll pick Pythagorean identity. And we know by the Pythagorean identity, that is equal to 1. Okay, so what we've done here is we've proved this identity is true. We started with the left side and we algebraically manipulated it until we ended up with the right side. So we did all of this work to prove that this expression was indeed equal to 1. So our proof is complete. We'll do a couple more here. All right, our next one here, we have establishing identity. We have 1 minus sine of theta over cosine of theta is equal to cosine theta over 1 plus sine theta. So again, this maybe is not the most useful formula, but the idea is that if we can develop this thinking about how to algebraically manipulate these expressions, then later on in your calculus career, if you needed to, we have the tools to do that. So what we're going to do again is we're going to start with the left side, and we're going to rearrange or algebraically manipulate the left side until it looks like the right side. And then once we've done that, we will have proved the identity. Okay, so again, my math lab is going to walk you through this step by step, which is helpful because it gives you a lot of guidance, but also it kind of doesn't make you think. So if you are going on to higher maths, you should think about how you might be able to prove this, how you might be able to rearrange the left to look like the right. Okay, so the first instruction you're going to get here is we are asked to rewrite the left side by multiplying the numerator and denominator by 1 plus sine of theta. So we didn't have to figure that out on our own. My math lab told us that. So we're starting with the left side, 1 minus sine of theta over cosine of theta. And we're going to multiply by 1 plus sine of theta over 1 plus sine of theta. So first thing we'll do, we'll FOIL out the numerator. So FOIL stands for first out, inner, last. So first is 1 times 1 is 1. Outer plus sine of theta. Inner minus sine of theta. And last minus sine squared of theta. In the denominator, I'm just going to go ahead and leave this as cosine of theta times 1 plus sine of theta because it's not really a benefit to multiply that out. We see here in the middle, we have plus sine of theta minus sine of theta. Those cancel out. So we get 1 minus sine squared of theta over cosine of theta times 1 plus sine of theta. Our next instruction is to write the numerator in terms of cosine. So we know Pythagorean identity says, this is not our work, here's kind of a side note here. We know that sine squared of theta plus cosine squared of theta is equal to 1. That's the Pythagorean identity. So here what I want to do is I want to replace this with something in terms of cosine. So if we look at this equation, if I subtract sine squared from both sides, I get that cosine squared of theta is equal to 1 minus sine squared. So up here where I have 1 minus sine squared, I'm going to replace that with cosine squared. Okay, so we've written the numerator in terms of cosine. The next step on my math lab, it's going to ask you to simplify. So we should reduce our fraction if possible. We see the numerator and denominator both have 1 factor of cosine, so I'll cancel out a factor of cosine. That leaves me with cosine of theta over 1 plus sine of theta, which is the right side. So if we start with the left side and manipulate it until it looks like the right side, our proof is complete. Oh, I should mention, there's a couple of things you might see in math proofs at the end of a proof. Sometimes you'll see a little square like that. That means the proof is complete. Sometimes you see these letters, QED stands for an expression, quid erat demonstratum, which means what was set out to be demonstrated is done. So if you ever see these later on in your other classes, this just means the proof is done. This means the proof is done. Okay. All right. The other thing I should note here is that my math lab is very restricting. We have to start with the left side and manipulate it until we get to the right side. However, sometimes in proofs, that's not the fastest way of proving this. If it was me, what I would do to prove this is true, instead of starting with the left and moving to the right, if I was just asked to do this on paper and I wasn't limited by an electronic system, I would just start by multiplying both sides by cosine and multiplying both sides by 1 plus sine of theta. Right off the bat, I end up with the Pythagorean identity, which we know is true, so we could actually have this proof in about 1 or 2 lines. So there is more than one way to approach a proof, but if you ever don't see a quick way out, we would always start with the left side and work to the right side. Let's do one more. Next one here, we're asked to establish the identity sine of theta over 1 plus cosine theta plus 1 plus cosine theta over sine of theta is equal to 2 cosecant of theta. Okay, so again, what we're going to do is start with the left side of the equation and rearrange it until we get to the right side of the equation. And again, my math lab is going to prompt us through this. So the first thing my math lab tells us to do is to add the fractions on the left side. So in order to get common denominators, our common denominator is going to be 1 plus cosine theta times sine of theta. So this first fraction I need to multiply by sine over sine. This fraction I need to multiply by 1 plus cosine over 1 plus cosine. All right, so our common denominator here is going to be sine of theta times 1 plus cosine of theta. And again, it's not really a benefit to multiply that out, so we'll leave it just like that. In the numerator, I have sine times sine, so that's sine squared of theta, plus, and then here I have 1 plus cosine theta times 1 plus cosine theta. If you want to use the special formula and multiply that out, you certainly can. I'll go ahead and FOIL it. So 1 times 1 is 1. Outer, we have plus cosine of theta. Inner, plus cosine of theta. And last, plus cosine squared of theta. Okay, now what we want to do is just simplify this a little bit. So here I have cosine plus cosine, so I want to make sure I rewrite that as 2 cosine. The next step on my math lab is going to ask you what identity we should apply next. And what we notice here is that I have a sine squared plus a cosine squared. Okay, so anytime we see sine squared plus cosine squared, we should think Pythagorean identity. So the next thing we'll do is apply the Pythagorean identity. So our Pythagorean identity, sine squared plus cosine squared is equal to 1. So these two things total is equal to 1. So I'm going to put a 1 in there. And I still have plus 1 plus 2 cosine of theta all over sine of theta times 1 plus cosine of theta. Our next step is to simplify. So 1 plus 1 is 2. So I have 2 plus 2 cosine of theta over sine of theta times 1 plus cosine of theta. Okay, we see that we want to simplify this, and our goal is to get to this right side. So I'm going to factor out a 2 here. So that I can simplify out this 1 plus cosine theta. Okay, then we get 2 over sine of theta. Our last step here is to apply the reciprocal identity. And what we know is that the reciprocal of sine is cosecant. So this is equal to 2 cosecant of theta, which is the right side in our original problem. So our proof is done.